Hi guys, welcome back to this channel. Today I'm gonna show you the ultimate RAG template that you can actually use in your N8N automations. This will not be an out-of-the-box solution for your business, but it will serve as a template where you can actually build your own use cases and you can modify this template to make it perfectly match your own business needs. At this point, you have probably heard of the RAG keyword. RAG is the process of giving AI agents and LLMs access to a knowledge base, making them domain experts. There's been a huge increase in the popularity of RAG because it is very easy to implement and it provides clearly a lot of value. One of the easiest ways to create a RAG for yourself without any code is the OpenAI Assistance platform, where you drop all of your files inside a vector store. And you can actually use that in both in their platform and in the API. Some of the biggest challenges with traditional RAG are the reliance on lookup method that can actually miss key context. Simply doing similarity search on vector embeddings may seem to work at the beginning, but you will quickly discover that they actually can break very often in production. The second challenge is the difficulty of handling full documents and especially tabular data. Working with CSV and Excel files on the past has been extremely difficult when compared with documents and PDFs. So, here is where Agentic RAG comes in. Agentic RAG simply is an improved system where the agent can actually reason about the queries. This agent now can use multiple tools, ranging from Postgres queries up to direct file extractions in order to get the right answers. Let's jump in the N8N workflow directly and see it. The system consists of basically three steps. First is the setup that we will actually run in order to set up the tables in Supabase, in our database. The second is the data ingestion pipeline, which is the more complex. And the third part is the actual usage of the agent in our chat platforms. So let's get over it, and we have some description here. This template will be in the resources link in the description, where you can download it and use it as you want. So let's check the first step of the system. So as you can see here, first we have three create queries, and we will run this like we have to run this all three one time, only the first one to kind of see how they work. And here we have basically in our Supabase, let me show you, we will have four tables. One is document, the second is document rows, third is document metadata, and these are the three. These are considered our database, and four is chat histories, which will hold the history of our usage. We'll talk about this later. So first things first, we're going to create the documents, which holds the content, so the chunks that we actually use, document metadata, and the embedding vector itself. So a note here, we will use the dimension of 1536 because we will use the OpenAI embeddings version 3, the small model. If you want, for example, this is for cheap and quick testing. If you want for production use cases, using the V3 large model is suggested, but they have a different dimension. They have 3096, I think. It's different. So if you choose that model, you're going to have to modify the vector size in the database as well. Not that. And basically, yeah, we create the document, and we also create a match documents function, which performs the similarity function in the vector search while filtering for metadata. This is the first one, and I have run this. So you have to run this. The document metadata is, again, as you can see, let's go over here. So we have the title, the URL of the file, and the create time, and the schema. The schema only refers to CSV to tabular data. The schema only refers to spreadsheets. So as you can see, like we have these are like documents and PDFs, and this is a CSV file. And the third table is the document rows. So this is only for spreadsheet data again. As most of the complexity comes from the spreadsheets. And this is because the spreadsheets actually are the hardest ones to actually parse and actually get correct data from them. the biggest part of our system here. It's about the spreadsheet data. So yeah, and the document rows contains, as you can see, it's that's ID. This is a file, and it has the row data here as session. And yeah, we'll talk about this a bit later. So this is the setup, 3 tables. And the step 2, this is the ingestion pipeline. And we have a source folder where our knowledge base lives. And this is like the start of the pipeline. And the end of the pipeline is our Supabase tables. So for the source of the knowledge base here, we will use Google Drive. You can use pretty much anything like Dropbox, even local files, some AWS S3, anything you want. And here we have 2 triggers. So we have on file create and on file update. And this was a specific folder that we have. Where is it? Here. So we have created this folder where we have some documents. And if we go back, so where is it? Here. Yeah, so we watch for this. And if you run this, so this node will run on when we upload a new file to a document. And as you can see, we get all of this data. So we get like the type, and we have the URL of the file somewhere. We don't need most of these. So it's like we need only the file type, the URL, and its name. And this is the on file create, and we have on file update. We have a different trigger. So we can see what's updates. There is one thing missing here. So N8N does not have on file delete. So if you delete a file from the source, from the drive folder, we want to trigger and delete the data in our database. So we hope this gets added soon. And if it does, we'll modify this and include it in a new version. And here you can see a loop over. So what this does is if we upload one file or like update one file in our folder, we don't need this. But if we do 2 or more files, we need, because it's run actually process one file. So we loop over how many files we do have. And next step is we get the file ID and we set it in a variable so we can access it later. And you have the ID, the type, title, and URL. These are like the variables. And as you can see, the last run here was about spreadsheets. And you see like the name. And this CSV file has dummy data. We generated them with GPT. And we have this, and we're going to perform some queries in the demo in a bit. But they are like typical like Excel files that every business has. This, as you can see here, we have 2 Supabase nodes that we delete rows from the documents table and the documents rows tables. And we do this because this will perform only on file update. So if we have a file, so let's say we have a file with 10 chunks of data, and we update that file, and like maybe the new file, let's say it has only 5 or 6 or 7, but has less chunks of data. If we do not delete the old file from our database and its content, we will still have these deleted chunks in our knowledge base. And although these at first glance might seem okay, in an actual production use case can drag down our performance because it might get retrieved while it shouldn't even be there. So in this case, we delete the rows, and if we are on a file create, we will not find any rows, so this won't error out. This time you can actually see it. So after we delete existing entries, we try to insert. The next step is inserting metadata on the metadata table. And as you can see here, we match the document metadata table and we set the ID, title, and URL. So one other thing you might note in this case is and if we zoom out, you always see sometimes we use Supabase nodes, sometimes we use Postgres nodes. Both of these target the same tables. We do this because sometimes for some operations, N8N provides us with existing Supabase nodes that makes it easier. And for operations that it doesn't provide a specific integration, we just use typical Postgres connections. So it's a choice of like the least hard. Doesn't really matter which one it is. So next in line is the actual download file function. Because we do not have the file itself, the drive triggers only get the file metadata. And now we get it, we know, because we know the ID, download the file, and we have the binary form. And I think if we view it, no, we don't actually. So if you view it, now, if it was a PDF or a Google Doc, we would actually see it here, but this is the CSV, so we cannot view it now. Anyway, so here we download the data, and now we check to see its type. And this template only we have integrated 4 data types. So it has PDFs, CSVs, Excel files, and Google Docs. So it's like Microsoft Word. And based on this data type, based on the file type, we have different processes. As you can see, the next step is extract the text from the file, and you see like the PDF, the document, the CSV, and the Excel. If you go here, if you check, we also have many more data types. So you can have XMLs, you can have base64 strings, you can have JSONs, you can have calendar formats, HTML. So you can add all of these by default. And we can always do more with custom code on it. But the template only has these 4. Adding more would just like make it unreadable in this case. So every business has its own needs and can modify this as needed. So after the switch, we go to the extract. And as you can see, we have, these are categorized, these are fed in like 2 categories. So the bottom 2, the document and PDF, actually only, because if we open the PDF file, we don't have any data now. Because we only need the text, and we extract the text and we pass it into the upsert function we'll talk about later. After that, we do that, and we also do that for the document file as well. So we get the text of the document and we just upsert it into in our knowledge base. When we have a CSV and Excel file, as we need to do some pre-processing, and this is because of the spreadsheet, because LLMs cannot handle spreadsheets very well. And in both cases, we kind of have these 2 processes in parallel. So because now we have a CSV file, we open this one. And the first is insert table. We have this Postgres node, which is it inserts the rows in the document rows table. And as you can see here, we have every row of the sheet gets inserted into the table. And this is because when we fetch data from spreadsheets, we will fetch the text like they are, like if they would be a document, but we will also perform SQL queries on the table itself. And we use the ID to kind of filter between documents. So for example, if we go back to the data, if we had, for example, if we said, give me, let's say, all of the locations from the businesses, having these as a text file, so if we actually like Control C, and let's say, so if we paste it like this, it will probably work because LLMs have gotten pretty smart. But if we ask something like, okay, so give me the average employee count for Dallas, or maybe, no, I see its town is unique, so give me like the sum of the revenue, or give me the mean or the median or the min and max of the revenues, or we can do it per year. And we can do some data analysis like we do on Excel and Python and SQL. And using SQL, so we will be able to perform analysis on the spreadsheets. And this is one of the main reasons why this template can perform way better than simple RAG, the ability to perform analysis on tabular data. In this node, we set up the tables, so we can perform SQL queries, and also in parallel, we aggregate the results. Like we perform like a for loop to aggregate all of the rows, and then again kind of combine them. So we see the output is like the select of all of the CSV and paste. This is a one large text file. And after that, we also set the schema, because one other thing, in order to do the analysis on data, and because the LLM will generate the queries on the fly, and in order to generate the correct queries, it needs to know the schema exactly how it is, because if it doesn't, it will guess and it will get error all the times. So in this case, we can see the schema it's the first row of our, so we're guessing that the first row is our headers, and we're taking this granted. And we have the first row, we have examples of the first rows on how they actually do. So for example, we have what is the business ID, we have business, like the business names, the location, how it is, and all that kind of stuff. And we save that one, and we update the schema in the documents metadata. So if we go back to our table here, because we have one CSV in this one, so we have the dummy CSV, you see that it's the only one that has the schema. And let's go back to the template. So we, at this point, we have extracted the text from the documents and the schema. We have also saved the schema if it is a spreadsheet. And now we're gonna insert it into the knowledge base. So what we have to do, we're gonna use this default node for the vector store. And what this does is it takes, so this is the typical part where we actually have text and we split it into chunks and we generate embeddings for each chunk and we insert it into our knowledge base. And we use, for the embeddings, we use the version 3 of OpenAI's model. And for the splitter, we use a default splitter. So this is of chunk size and I have it at overlap 0 at the moment. Chunk size is relatively small. Nowadays, having it at 2000, maybe 2500 with an overlap of 200 or 250 characters is good enough in most cases. Yeah, so this is pretty small, but I kept it small because I had a few documents to kind of test it, and we wanted to have like multiple chunks. So we split the chunks, we split the input text with chunks, and we generate and upsert them into the, doesn't open, and we upsert them into the documents table here, as you may see. So this is the ingestion, and this will work. Let's test it. We have a file. Yep, it got one. And yeah, so for example, let's see which file is this one. So it was a dummy CSV, and as you can see, it kind of entered. And so this is the ingestion, and this works with 4 data types, as we said before, and can be extended to basically everything because all kinds of data can be categorized, belong to 2 categories. Either text form, it's the PDFs, the free-form text, even the HTML and XML can be put in that category. And the second one is the tabular data, where we actually have structure inside that. So now that we have ingested our data, it's time to actually use the agent itself. And so let's go to the step 3. And here we have our triggers. We have the chat message for testing, and we have a webhook that can be connected with any chat platform. And we can also have direct. So if we have, for example, from Telegram or Slack and Discord are the most popular ones. But webhooks allows us to kind of connect everything, every chat interface basically. So we receive the message, and we have the fields here where we actually, come on, open this, where we said the session ID and chat input. And chat input is the message, and session ID is our conversation ID. So because in each conversation, in each turn, basically, we will store the session ID in the supervised table. So we have a chat history. And here we use a typical tools agent from N8N. And we use the tools one because we have like multiple tools. And we have the prompt here. The prompt structure is, as you may see, this is a fairly simple. So we are personal assistant, and you can do RAG, and we describe documents table. And so this is like a very simple prompt, and we instruct the agent to actually start by performing a RAG, and we tell it as well that can also do SQL queries, and we also tell him that always tell the user to find the answer. Do not make something up, and this instruction can actually reduce hallucinations by a lot. So this is a very basic prompt, and this is like something you can start with and start iterating. So there is one simple trick that you can actually make in order to improve the prompt by a lot. And now, depending whether you use GPT models or Claude from Anthropic, we're gonna because here we use the GPT-4o model, the base one. We're gonna do it in OpenAI. Anthropic has one itself, So in order to kind of improve the prompt, what you can actually do is go to the the way that you can actually improve the prompt and kind of make it model specific is you go to the playground of OpenAI, and here the chat. So this is the platform.openai/playground, and in the system message you can actually generate a system message, and this uses OpenAI's like prompting best practices. And what you can actually do is instead of generate something from scratch, you can something. So we input our very simple prompt here, and we actually use OpenAI to kind of generate the prompt itself. And this will give it a lot of better structure. It will basically create sections on the prompt, as you can see here. And yeah, so it's way better. And we also have the prioritized factual accuracy. One thing to note here is you kind of need to see if the prompt actually has the tools that it had before, so it can actually work. What I mean is like we had the documents in the documents table in the prompt before, and we kind of need it again because this is specific to our use case. And it is, yeah, so we can actually see document rows here and document data and documents table, so it can actually keep them. So we're going to use this one, and you can go back and forth and always test this one. And I'm going to save this for now. So this is the prompt. And so we have the agent has three main components: the model, the memory, and tools. Model, we use the 4.0. For memory, we use because we save the chat sessions in Supabase, we use the Postgres tool, memory tool, as you can see here. So based on IDs, we see like here we had two back and forth. And if we open it, actually, yeah, we only need to save it, nothing else. And now go to the tools. And in the tools, we actually have four different. We have the list documents and get file content, which actually is, and these ones also have prompts by descriptions so the LLM can understand what it is. So the list documents is the tool that actually retrieves all available documents and the stable schemas for CSVs. That's why document names actually matter, because they are a high level summary of the content that the document actually provides. So even if you have like dummy data, calling it dummy doesn't really help. So calling it like, I don't know, business name, like February performance or something like that, actually can help the LLM understand. And the prompt and the description here is very simple. So it's a tool to retrieve all available documents. And yeah, so that's it. It connects to the document metadata. This is the one. And we have the get file content, which is similar, and except like this also performs SQL query, and we perform a query here, and we actually have an input, which is the file ID, that because this works on the documents table, and we store all documents in that table, and we actually need to filter it by ID. And we have and the description again shows that we need to kind of, and the description shows that we actually need to reference by the ID as an input. And we have the query document rows. This is, let me open the description. So this one actually performs the SQL queries in the table, in the document rows table, and this performs the SQL queries in this table. And when we say the SQL queries, we mean basically the data analysis. And run SQL query. Yeah, and the prompt, as you can see, is similar. We have in our input, we need actually the file ID, so we can actually filter the query, and we actually showcase the queries themselves. We give it two examples. And this is the third tool, and the fourth tool is the RAG tool itself, the base one. So this one retrieves 5 documents. The limit of the increased documents you need to kind of configure it with the chunk size. So if we have a chunk of 1,000, we can retrieve 10 plus contents easily, because it would be roughly 10,000 characters, and that's like 750 tokens, 7,500 tokens, which is not much, both from size and cost. If you want to kind of do it like 2,000 or 3,000 chunk size, having it like at 5, it should be enough, more than enough. And we don't actually need to increase by a lot in this case, because we also filter by metadata. so we kind of limit our garbage chunks that we actually fetch. So we have this case, and again it uses the embeddings in the query and gives us the response. So time to test this, and we're going to test this in the chat here. And let's ask it, wait a minute, what documents does it have? Let me check, because I see it's in brief. So one of the documents is, let's open this one. And this was a project description I had in my computer. So let's ask it. It was like for a formatting tool. So let's ask it for the images. What dimensions should they be? Let's go here. What dimensions should the images be? And here. So we get the chat, get the action. So it's time to test this. And let's go. And actually, I have this document, which is a report generation tool, and these are the requirements. I had this on my computer. And actually, let's ask this for vehicle registrations, like the format it should be. What format should vehicle registrations be? So we use the chat, and this doesn't have the previous ones. And we have the OpenAI, and this is just the output of this, as you can see. Okay, you can't see it yet. So the output, as you see, it did where it is. So here, the finished reason is a tool call. So if you see rendered, we don't see any text because it didn't answer the question, but it called the tool, and it actually called the Subabase, the RAG tool that we have here. And it input the query vehicle registrations format, and it fetched 5 documents. And yeah, do we see here? No, we don't have it. So if this tool performed the embeddings, and it retrieved the output, and yeah, so it answers the format for registration typically follows. So we have first mention and subsequent mentions, which is actually correct. We have the first mention here. It has a specific type, and the subsequent mentions different format. And it's the same, and it gives us an example. So this seems to be working. Now let's try the CSV file, and let's see what we ask this. So let's say how many, what should we ask this? How many businesses have more than 70 employees? More than 100 actually. How businesses have more than 100 employees? Let's see. So let's see what we got here. This used this is the memory. It's okay. And it used the RAG. It didn't use the SQL tools to actually get this. It used the RAG ones. And yeah, so we have more than 100. We have only 2. So it's Silverline and Global Connect. So it's correct. And yeah, it is correct. And it didn't actually use the SQL. I think it might be because it was easy. Let's try it again. How many businesses have more than 50 employees? So we list the documents. Yeah, there are 9 businesses with more than 50 employees. Let's test it. 51, 2, 3, 5, 7, 8, 9. Okay, yeah, so the one that's 50 didn't count it. And as you can see here, we have the tool call, and what it is, tool calls, and it lists the documents. That's the first step. I think in this case, it was searching for the correct file. And let's see the second LLM. It was, see it here. And we have the query documents. So this one, actually, why there's not, I don't see an output JSON here. It's okay. So in the second step, it actually used the query documents. So it performed a SQL query with the correct ID, which actually got from the list documents, as you can see here. And so it performed select count all from documents more than 50, and it got the correct 9, and we see it's the correct number. Okay, let's try harder one. Let's try what is the mean. Yeah, let's typical analysis. Not here. Yeah, here. What are the mean, max, mean, median of the revenue of the businesses. So we're actually going to need to calculate it ourselves, this one, and we have mean. So in order to calculate it, I'm going to do something else. because I don't know how to kind of work with CSV files. So I give it a here. Calculate the mean, max, mean, and median of this using Python code. So it will actually perform the analysis. And it got here, and we have the numbers. So let's first check. Yeah, I think it's this. Wait a minute. Sorry about that. And I think it's the same. So yeah, here perform the mean, max, mean, and median. Python, and has these values. Let's go to our chat here. And actually, let's see them. So first, we list the documents. First tool call, and then we did it together. We performed the RAG, and I think if you see in the previous session, we actually cannot see that. In the previous session, it has a chat, listing documents, a second chat, and then using the RAG. Now it kind of used it immediately because it saw it from the chat, and I think it's because it saw it from the history that needed. And then let's go to this one. Here we have all the chunks, and here we perform the SQL query. So if we see, we have mean, max, average, and for the median, there's no default, because the median, for people that don't know, is actually the number in the middle. So if we sort the numbers from the lowest to the highest, so let's say if we have for numbers from 1, 2, 3, 4 up to 10, the median would be 5 because it's exactly in the middle. Actually, is it? Yeah. And yeah, so in Python, as you can see, we have the median, the NumPy library. So we calculate it easily. It's 1.2 million. But in SQL, there's not. So you can actually have to do it by hand, let's say. So you have to make the function, and it actually did. So for numbers, we actually have the same. Yeah, minimum for 30, maximum 3 million, 1.33, the mean, and median 1.2. So it seems to be working, and it actually seems to be doing pretty well data analytics on the data. And yeah, so that is the test. So that is the agent. Oh, we covered all 3 steps of the RAG template. And basically, this serves as a skeleton of what you should build on. Some of the things that you can actually do to improve this, changing the vector embedding model to the version 3 large, it's kind of required. Playing with the chunk size and chunk splitting, how we actually split chunks. This one it's also important. Something you can add is re-ranking, and comment below if you actually want to modify the template to actually include re-ranking, which is tend to be important nowadays. One other thing to actually improve is the model itself. So in this case, we used the GPT-4o, which is a very good base model. If you have larger databases with multiple files and multiple schemas, using O3 and O3 Mini can actually improve the quality of the system because it will make fewer errors compared to the 4o model. Okay, so by making these 3 changes, you can easily increase the performance by a lot. Okay, so you can find the template below. It's on the resources.apexlabs.ai URL. Now, if you are running an established business or you are a funded startup that is looking to consult with me on building AI solutions, there is a link in the video description that you can use to book a one-on-one call with me. Thank you for watching this video. See you in the next one.